Okay, I guess it has started now. Okay, I guess it has started now. Yeah, it has started. Right. So today's link will be like split into two. Now let me go back to the class. So I think Atharva Sanjay More had asked us a question, right? And his question was, okay. So let me write down the question here. So his question was, let me create another screen message. Okay. Can't I take the total number of inputs or total number of the size of the variable as user input? Correct, Sanjay? And the first thing that I mentioned was earlier versions of C compiler did not allow variable declaration at any part of the program. Okay. So earlier versions of C compiler did not allow variable declaration at any part of the program, though it works now with the latest standards. Okay, there are situations where dynamic memory allocation becomes important. Okay, and we were trying to understand. Okay, is my screen visible in both the Google Meet as well as yeah, I guess it is visible, and the OBS Studio, yes, it is visible. Okay, so over here I have searched for a particular topic called linked list. Okay, and you can see that a linked list is a data structure, okay, that is there in a computer program. Now in this linked list, right, over here what we can see over here is actually you know, this is like the train bogies. Okay, so there is one train bogie called A, another train bogie called B, another train coach called C, and another train coach called D. And in the first train coach, right, there is a small metal link that is there, which you will connect with the screwdriver and the spanner and everything to the next coach. Okay, so then from the coach B, you will connect to the next coach C, and to the next coach D, and so on, right? So you have 4 coaches A, B, C, D here. Now it is possible for me to put another coach between B and C. Okay, over here it is possible for me to put another coach between A and B over here. So what I will do is I will connect the A coach to the intermediate coach that I want to connect to, and then connect that coach to B. Correct, right? So this is the concept of something called a linked list. Okay, so linked list contains some data and the next connection to the next coach. So that is what you need to understand. So in this kind of a situation, right, we are actually not sure whether we are going to deal with 100 data points, or whether we are going to deal with 1 lakh data points, or whether we are going to deal with 1 crore data points. And it may not be possible for the user to give an input as well, because there won't be a user interaction as well. Say let us say now I'll show you something else as well. Okay, so right now I'm going to show you something called another data structure called B tree, where the idea is that I will keep on entering some input, okay, and I will keep on making it into a tree. Okay, now let us assume that for the previous problem and the new problem, okay, for the previous problem and the new problem, let us assume that we are doing something similar to web searching or web crawling, okay, which is parsing and working with millions of pages on the internet. It need not be millions, but it can be billions. Here in these situations, there wouldn't be a user per se, okay, user as such. Instead, it will be completely automated, and the program is doing some major part of the work. Okay, so Sanjay More.
Yes, sir.
Okay, so right now I have tried to explain to you, like from the first 2 points, 1 and 2 over here, I have mentioned that although the earlier versions of the C programs, C programming compilers did not allow variables to be declared other than at the top of the program. Nowadays it is not the case. Even you can declare the variables at the middle of the program as well. But even in situations like that, you could be working on things like creating trees or creating linked list, okay, or solving some problems which cannot be solved directly using arrays. Okay, so you may have to you do not know what will be the size of the array that you have to declare before you run the program. Okay, you do not know. You will have to definitely declare the array as and when the need arises. So what I am saying is, there could be cases where you will not be in a position to determine the number of data points you will be processing or to be processed. Okay, in these cases, it is very important that you have to allocate the memory dynamically only. Imagine say int student names 10,050, but what if the number of students is 10,001 or 10,002, right? So we have to use dynamic memory allocation in situations where we may need more storage as required during the program run time. So what does program run time mean? During the time when the program is running, I have determined that the number of students is 10,002 or it is 20,000, right? Or it is 1,20,000, whatever be the number, right? We may still have to go for something called dynamic memory allocation, and we may not be in a position to use static variable allocation like Sanjay had asked. Okay, now that was a very good question that you asked, Sanjay. Okay, now going back to the program that we were writing, right? So over here, right, I am asking the user to enter the description length. So the description can be 100 characters long, or it can be 200 characters long, or it can be, you know, very long, something like what we have given over here, right? So here in this one, let me see. Okay, it's a very long string. Now let us try to compile the program. So GCC malloc example -o malloc example. So it compiled. Now let us try to run the program. Okay, /malloc example, and let's enter the text width to be 100, which we are very sure it is greater than 100, right? So what will happen is, oh, this program actually ran, which shouldn't have. It should have actually resulted in a segmentation fault. Okay, so let's try one. Even one it worked, which is incorrect, right? Because I am trying to enter value 1 and I am saying that the, you know, let me print the size of array as well. Printf size of array enter by user. Right, so it is printing it to be 1, okay, while in reality it cannot be. Okay, it should not be, you know, printing the description. This is incorrect, and the reason why this is incorrect is because you know, this should have actually resulted in something called segmentation fault. Okay, so
Sir,
yes,
while we're using the malloc function,
yeah,
we're basically giving some storage space for the variables that will be entered, for the text that we enter, sir. So in the what is in some scenarios, sir, if the input is too large, if it is more than the allocated memory, sir, then it will be at fault again. So what will be the function? What will be the advantage of using a dynamic memory, sir?
No. So that is what I am trying to tell you. Okay, so with the kind of description that I gave you, and with the program example that we were trying to run, right, this was actually giving us an erroneous output. Okay, so just take a look at the input that we had given. We had asked it to create an malloc with only 1 size of character, right? So which is again 1 byte. And we very well know that in 1 byte you can store only the character capital T. Correct? Yes. And the rest of the characters are actually not bound to be stored over there. If it is stored over there, we should understand that it is not correct. It is actually by mistake. And this should have actually resulted in something called a segmentation fault. Okay, so let us try to see whether we can do something like star description plus 10 . Can I do it this way? And I'll just copy paste this thing. And I'm going to print the description after this particular step. So over here you can see that I have entered the positions 10, 11, 12, 13. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11, 12 and 13 were put as capital T, and this should have actually resulted in a segmentation fault. Okay, so let us try to understand what exactly is this segmentation fault. Okay, okay. So in C programming, so this is saying accessing array out of bounds in C or C++. Those students who may have learned a bit of C programming or a bit of Java programming earlier might have seen that if, or in this program itself, right, in this one there is an exception that is given, that is generated by Java. So in this one in this one they say that in the Java programming language, if you are trying to access a memory element in an array that is not actually allocated to your array, then it would actually end up in an exception called array out of the bound exception, array index out of the bound. But in the case of C programming language, right, there is no such functionality, and the programmer need to take care of such situation. So this is very important that you understand. Okay, so the programmer need to take care of this kind of a situation. Okay, so C don't provide any specification which deal with problem of accessing invalid index. As per ISO C standard, it is called an undefined behavior. Okay, so that is not something that is defined. So whatever program that have run over here with the malloc example that we have seen, right, with the description of the length of the description to be kept as 1, and the malloc creating an array of size only 1. Okay, in this situation it should have resulted in an error, but unfortunately, I am telling you, unfortunately this has not resulted in an error. But do not think that this is actually correct. This is actually incorrect, and the reason why this is incorrect is, in C programming language, this is an undefined behavior. And what is an undefined behavior? Which means that it can work on some way on my computer, and it can work in a different way on another computer with another version of the compiler. So the undefined behavior is a result of executing computer code whose behavior is not prescribed by the language specification to which the code can adhere to for the current state of the program. Example memory. This generally happens when the translator of the source code makes certain assumptions, but these assumptions are not satisfied during the execution. So see this particular example. So if you are accessing a non-allocated location of the memory, right, non-allocated location of the memory, let us say that there is an array with 5 elements, okay, 0, 1, 2, 3 and 4 are the indexes, and you try to access the index 10, okay, that is the 11th element. It should ideally, result in a segmentation fault or an error, but you can see that tries to print the garbage value. Okay, and second one is, let us say that we are trying to access and assign some value. So this is a segmentation fault. Okay, the program can access some piece of memory which is not owned by it, which can cause crashing of programs, such as segmentation fault. Okay, so this kind of thing will cause the program to crash when the program is running, because I have already told you this. It means that when you are actually running your program has been allocated certain memory location in the computer memory. Okay, let us assume that to be a boundary location. Okay, so you are supposed to put everything in that memory location and read only that thing from the memory location. Now if you are trying to access a memory location that is not allotted to you, in that case you will actually end up in something called a segmentation fault. Okay, so it is very important that you always stay inside the bounds of the array in C programming while using arrays to avoid these kind of errors. Okay, it is in this particular article, right, it is not saying that it will always produce an error. It is saying that the behavior is something called an undefined behavior, and an undefined behavior means that it could be different for different situations. Say for example, if my computer has been loaded with a lot of programs, and that memory location has been assigned to somebody else, right? So in this particular program, in this particular example, maybe this memory location has not been assigned to some other program. Okay, and it has not been assigned to me also, but somehow we were able to access it because it was not assigned to some other program. Now if this was assigned to some other program, then definitely this kind of a program where I am assigning capital T to any of the character would actually result in an error, would result in a segmentation fault. So in this particular program we have seen as an example in this particular program, yeah, we have seen the use of malloc. Okay, malloc is used to dynamically allocate memory. Okay, it takes one argument, the size of the memory location to be allotted or allocated. Okay, the size of the memory location to be allocated, and in our example we have given it as size of array, or let us say 10 into size of char. Okay, I have to do one more thing, man malloc. Okay, so I just opened the Linux programmers manual for malloc. Okay, and you can see that malloc, free, calloc and realloc, allocate and free dynamic memory. And let's try to read what is malloc from the description. The malloc function allocates size in bytes and returns a pointer to the allocated memory. Okay, so we can understand that it allocated some size in bytes. Okay, so if the size of array that that's a user entered value, right? If it is 50, then it will allot 50 bytes, and it returns a pointer. Okay, it returns a pointer, and that pointer is what this description is holding. Correct? Now one more thing. Hey, there is one more thing. If size is 0, then malloc returns 0. Can we try entering 0 here? And despite it being null, it still worked, which means that it is an undefined behavior and we should not be doing it that way. So right. So in essence, let me show you that once again. malloc function allocates bytes of memory and returns the pointer to that. In malloc returns a void pointer by default, meaning that is of no particular. So this is another place where I think I could be making a mistake. Particular type, okay, which needs to be type casted to the appropriate type. Okay, so let us take a look at this. So malloc, right, we can see that it returns a pointer. malloc returns a pointer of type void. Okay, and we have to typecast this pointer into the appropriate type. So let us do that. So I'm trying to typecast it into a character pointer, and I'm going to enter the value. Can I try -99? Yeah, this one finally gave me a segmentation fault. Okay, so when I tried to enter the value, it actually said that error, unable to allocate required memory, and it gave me a segmentation fault. Okay, so what are the things that we have learned? We have learned that there is a function called malloc, okay, that is used to allocate memory dynamically. What does dynamic memory allocation mean? It means that we are not reserving the memory space required by the program at the time when we are writing the program. Okay, we are saying that we will not do that. So let us say if we have a char name of 100, this particular line which I am highlighting, char name of 100, right? This is a static memory allocation. Static memory allocation. Allocated 100 bytes of memory for name, for the variable name. Okay, and for this one also, right, it is a static memory allocation. Static memory allocation allocated a character pointer. Okay, and this is again static memory allocation, allocated an integer variable. All right, and these are all static. The only dynamic memory allocation is this place. Okay, is the place where you use the malloc function. Now let us say if size of array equal to 0, okay, return 0. If I do it like this, right, let us say that if this condition, if this if condition gets evaluated to be true, then the program will exit, meaning program will exit before it can allocate the memory while the program is running. Do you follow what I am trying to say? So what I am trying to say is that if in the program, so in dynamic memory allocation, you are allocating the memory, okay, malloc allocates the memory dynamically, okay, malloc allocates the memory dynamically, and it allocates the memory during runtime of the program. Okay, if the program exit before the malloc statement gets executed, then that memory area is never allocated, is not allocated. Students, especially everyone who asked questions like Sanjay More and other students, does it make sense like what we are trying to explain? So what I am trying to explain over here is something called dynamic memory allocation, and in dynamic memory allocation it means that rather than me writing int name 100 or int description 200, okay, during the program's running time, if I allocate the memory location dynamically depending on the requirements at that period and time, okay, that is dynamic memory allocation. And there is a particular function called malloc that you can use to allocate the memory for a program dynamically, okay. So when you use malloc function, what malloc does is it will return the pointer to the allocated memory location. How much memory location will be allocated? That much memory location that is mentioned in bytes in the memory allocation function. So in this particular program, right, I am going to make some changes. Can I delete these comments, students, and this if condition also? Students?
Yes, sir.
Okay, so I am going to delete these, that if condition, and I am just going to delete these comments also, okay, so that it will be more readable. Now instead of size of array into size of character, I can also mention it as size of array, because I know size of char is always 1, right? So I'm sorry, size of char, right, is always 1. So which means that I don't have to multiply it by 1. I can just give size of array, and I try to compile the program. It compiles. I can change it, okay, and instead of size of array, I can give it as 200. That will also work. Okay. Okay. and if I want to allocate, let's say, integer, then what I need to do is I have to typecast the thing into an integer pointer, and I have to do size of int. So that will be 200 into 4 will be 800 bytes of memory. So or else I can just give it as 800. Okay, so that is size of array into the size of the type of memory to be allocated. And okay, this cannot be integer pointer because that will end up in an error. Okay, I have typecasted it into a character pointer because malloc returns a void pointer. So right, so here we have seen an example of how we will allocate the memory dynamically. We have seen a function called malloc, okay, and once the advantage of this using dynamic memory allocation is that when I am running a particular program, let us say, and during the runtime I have to process some data. We have always seen that whenever we have more number of Chrome, that is Google Chrome tabs, right, the whole memory location, whole memory usage will keep on increasing. Okay, and when we so it will keep on increasing, the whole memory location will keep on increasing. Okay, the memory as in the memory usage, and when you close the Chrome tabs, right, you will see that the memory actually gets released, gets free. Okay, so with dynamic memory allocation, the advantage is that you will be able to so when you have more number of Chrome tabs, right, there are so many Chrome tabs that you have here, and you can see that the computer has used about 6.5 gigabytes of the primary memory already, right, and you can see that when you try to close the Chrome browsers or the tabs, right, then in that case the total memory usage will also come down. So that is just an example that I wanted to tell you about memory management. Okay, and the reason why I told you that is, so we have learned to allocate the memory. Now if we dynamically allocate memory, we will also be dynamically able to free that memory, which means that once we do not have any use for this variable description, right, or the memory that is allocated, which is being pointed by the pointer description, right, in that case you can actually choose to release the memory, okay, or you can free the memory, okay, using the function free. Okay, so far from the program, from the examples, we have seen that we have used the void function, malloc function, and now we are learning about the free function. Okay, so free description, that will be the way you will free that particular memory location. Okay, say if we have the program like this, at the end I can write free description. Okay, and can I try to print this description once again? Printing description again. Okay, so I'm just going to compile the program, clear the terminal, and I'm going to run the program, and I'm just going to enter, let's say, 500. Okay, you can see that I have printed the description once, and after I printed the description once, what I did was I freed that memory, okay, using free description, and then I went ahead and tried to print the description again. Okay, I freed the memory using the function free, and then I tried printing the description again, like printing description again, and you can see that it has not actually printed anything over here. And why would that be? Because this pointer description is no longer pointing to the memory location which holds this particular text. That is how you should understand. The pointer is no longer pointing to the memory location that is holding this particular text. Can we print, let's say, the how do we print the address of the percentage x so percentage x and okay, this is can I compile this and see what happens? So it is printing the address, but why would it print an address like that? Because it cannot print that address. It should ideally be giving me a free, right? Just let me check. Okay, so we use the function free, and with the free function we are no longer able to see the memory that is allocated. Okay, and we have seen that it works here over that, right, that way. And see, it cannot assign, it is not assigned the value null. Okay, it is assigned some value, but that memory location is now freed. That is what you need to understand. So we have seen two things. One is malloc, okay, that is a function which allocates an array of number of bytes and leaves them uninitialized, and it always returns a void pointer. Okay, and then there is another function called free, which will return a memory block, that is, which will free a memory block that is specified by an address. Students?
Yes, sir.
Is this kind of clear, like what we are trying to do? Say for example, we have those functions in the library called stdlib.h. Okay, the functions are malloc and free. There are two more functions, realloc and calloc. Okay, so let's try to understand what is calloc and realloc. So the function calloc, right, allocates an array of number of elements, each of which in bytes will be the size. So that is the function calloc. And then you have something called realloc, which is going to take in an existing reference and then reassign it with a different set of value. So these two are the major things that you need to understand all the time, malloc and free. Malloc is used to allocate a specific number of bytes of storage, and then it will return the pointer to that particular storage memory. And free is used to free that allocated memory. Okay, then you have two other functions called calloc and realloc. Students, is this clear, what we have tried to explain? And you can see that in this particular example, right, I have used pointer arithmetic also, right, pointer arithmetic to access a particular array location, right, and change the value. Correct, students? So if
Yes,
this
sir.
is clear, I will go forward. Okay, so what you need to understand in principle with regards to the memory management is that there are two functions mainly, malloc and free. Malloc is used to allocate the memory dynamically and free is used to remove the allocated memory. Okay, so it is no longer assigned, it will be released from this particular program. So in this particular example, right, they have also given the example for resizing the memory. So the resizing the memory, they have used something called realloc after the malloc was used for description. So you can see malloc 30 was assigned to description, and after that the size of size of description was changed from 30 to 100 by using the function realloc. So that is what I wanted to tell you about this particular thing called memory management, and I would like to show you something else now. Just a minute. So I wanted to actually show you something. I think I will have to draw that again. Let me take a draw. So this is something from the previous class. Okay, so I just went through the video once again and I figured out that one of my explanation for a particular thing was not totally accurate. I wouldn't say it was incorrect, it was not totally accurate. Okay, so I'm trying to tell you that explanation again, and this is regarding the command line arguments. Okay, so yeah, this is regarding the command line arguments that we were learning last day, right? So over here I told you that char star argv square brackets is a way for you to describe a particular two-dimensional array. Okay, although that being the case, what you need to understand here is argv of star, char star argv, this is a array of character pointers. Okay, it is an array of character pointers, and instead of depicting it as a two-dimensional array, right, if I depict it as this as pointer to this particular string and argv1 as the pointer to CS101 string and argv2 as the pointer to CSOE13 string, right, and argv3 as a pointer to CSPC34 string, that would be more accurate. Okay, so that is one thing that I wanted to tell you. Is that clear, students? This particular explanation from two-dimensional to an array of character pointers. So over here in today's class, I have covered two things. Which one is dynamic memory allocation, okay, and another one is better explanation to star, okay, char star rv in command line arguments. Earlier it was mentioned only as a 2D string array or 2D character array, while it has to be considered as an array of character pointers, okay, and let's say rv of 1 or 0 points to the 1D array containing the name of the program. Is that clear, students? So that is about we have learned dynamic memory allocation, and then I gave a better explanation about the command line argument, and now I want to actually cover another topic which is called files. Okay, so far we have been writing C programs and for a variety of small problems, okay, where the user types the input and the output is printed onto the computer screen. Okay, so far that's what we were doing, and usually we create a file called file.c, which is a C program source file. The file.c file is compiled using gcc file.c -o file, okay. Then the newly generated binary executable file is executed using /file. So over here I have written, usually we create a file called file.c, right? Instead of writing, usually we create a file called file.c. We create a file. We create a simple text file called file.c. Okay. So what I am trying to tell you is that when we were working with C programming, we have created multiple .c files, right? Addition.c, Armstrong.c, calculator.c, command args.c, hello world.c, glucose.c, factorial.c, factorial_iterative.c, correct? And when we had a drawing, it was called as flowchart_memory.odg, okay, and so on. Okay, so let us try to just go to the terminal, okay, and I'll do an ls. Okay, and so there is armstrong.c. okay, so there's a file called armstrong.c. you can see that I did an ls here in the folder 2021, and you can see that there is something there's a file called armstrong.c. now I'm going to print the contents of armstrong.c into the computer screen. So when I printed the or when I displayed the content of armstrong.c, I can see that it contains some C code, and it is written in English, right, with the special characters and usually English like characters. Okay, now I know that when I did ls, I know that apart from armstrong.c, okay, there is something called armstrong.out also, which is actually displayed in green color. So what I'm just going to do is armstrong star al h. Okay, so I just tried to list only the files which has the name Armstrong. So I have armstrong.c, and then I have something called armstrong.out, and I have already told you what these X stand for. Does anyone remember, students? Students?
Yes, sir.
Do you remember?
No, sir. No, sir.
Okay, so this is actually the permissions associated with this particular file. Okay, now armstrong.out is actually what? It is a binary executable file. So I'll do file space armstrong.c. It says that it is a C source file with ASCII text, so which means that it is a text file. Now I will check what is armstrong.out. Armstrong.out. Okay, it is saying something else. It says armstrong.out is an ELF 64-bit LSB Pi executable x86 64 version 1 dynamically linked interpreted for Linux 3.2.0 with the build SHA ID and non-striped. So I would say it is a binary executable. So there is something called executable that is mentioned over here, right? So I would say that it is a binary executable. I am just moving my video to the top on YouTube. Okay, so I am saying that it is called a binary executable. Now when I try to print what is there in armstrong.c, which is a C source code ASCII text, right, I will be able to print the source code of the particular program. Now on the other hand, if I type cat space armstrong.out, it has printed some other gibberish. Okay, it has printed some characters which a normal human being won't be able to understand and make any sense out of it. So it has printed some characters. So essentially, what did I tell you? I am telling you about something called so what am I saying? I am telling about files. Okay, there are two types of files generally called. One is the text file and next is a binary file. Okay, so text file, which is human readable. Not human readable. Okay. Text file will contain alphabets and information, while binary file, right, will contain data that the computer can read and understand in binary format. Okay, so there are two kind of files that I'm trying to tell you. One is called text file, which is a human readable file, and another one is called a binary file, which is actually not a human readable file. Okay, now I'm just going to copy this particular content, and I'm going to okay, wait, and let me move back to the text editor. So here I am just showing you the text editor called Emacs, on which I have edited the malloc example.c. So let me close this and let me open okay, so I'm just going to take notes. Okay, and in the meantime I will be able to show you certain things as well. So I'm just moving the content that I have shown you using the screen messages, okay, into a text file. Okay, into a text file. So I can rearrange the things later, but essentially what I am trying to show you is I'm just putting everything into a text file. Why not take user input on size of array? Then wow, I think I closed two things at once, which was not intended, but that was by mistake. Then you had free, we have also learned about text file and binary file. So when I was editing this particular file, right, 2021-december.org, you can see that it is a simple text file with a lot of things on that in that text file, right, and you can see that it is something that I have already shown you in the class, okay, in various classes, okay, or in various lectures. I have told you about functions, main function, algorithms, correct? I have told you about data types and so many things, okay, which means that if I actually look at the total number of lines in this particular file, you can see that there are around 655 lines, okay. And if I want to add a particular content anywhere, right, I can simply go ahead, keep the cursor, which is the black blinking box where I am hovering my mouse pointer right now. So that is called a cursor. Or if I take the terminal, right, then the cursor is where I am going to type in a character. So here is where I am going to type in a character, correct, or type in a command. So I have something called a cursor. So it's called cursor, okay. So it's called cursor, and this cursor is useful in, let's say that I want to I want to just copy this content and I want to paste it after this covered in class part, okay. Array of pointers, char star arg v, like this, okay. So I just pasted it over there, okay. So I just pasted over there the content that I want to paste. Now how is that possible? Because I placed my cursor at that location where I want to enter the data, and then I entered the data at the place where the cursor was, okay. So right, so with this cursor, right, I will be able to move to any part of the file, okay, read some 10 characters from where I have placed the cursor, or go back 10 characters from where I have placed the cursor. That is, from the location where I have placed my cursor at this point, I will be able to read 100 characters forward, or I will be able to go 100 characters back, and so on, okay. Let me give you another example for this particular thing. So I hope all of you must have okay, maybe this is a very wrong question, okay. So how many of you have seen an audio cassette? So some students, okay, Atharva Sanjay More, Abhishek Kumar Mohandi, and few people, okay, who have raised their hands over here, have seen an audio cassette, correct? Or you must have seen a video cassette also. Now, if I want to listen to a particular song, how can I do that? I have to rewind or forward the tape to that particular location, and then I have to figure out whether I have to play from the side 1 or the side 2, okay. So this is an audio cassette, okay. This is an example of an audio cassette. Here in this audio cassette, right, it will play the song where the cassette player's head, okay, audio cassette player head, okay. So there's something called a magnetic head over there, okay, which will read the content, okay. So the head will be something that looks like this, okay, that will be present in your audio cassette player, okay. So the audio cassette player, right, it would look something like this, or it would look something like this, and this head is the place where it reads that particular content from the magnetic tape, and then it is heard by you on the audio player. Okay, so you have an audio cassette head, and that head is where you are actually going to listen to that particular music. Now, if you want to go 10 seconds previously to the position where you are right now, you will press the rewind button. If you want to go 10 seconds forward from where you are at this position, then you will press the fast forward button. So you can press pause, you can press play, you can press forward, and you can press backward, which means that the head, if you consider as our cursor, right? If the head is similar to the cursor, then the cursor can also, if the cursor is considered to be similar to the head, right, you can use the cursor to go forward from a particular location that where you are at right now, and then you can go one by one. Okay, you can go there, you can place the cursor at one place, maybe read the next 10 characters, okay, or read the previous 10 characters, or at that particular location I can enter something, correct? I can enter something. So this is what you have to understand with respect to, let us say, I am going to write it over here, cursor and reading content of a file. Okay, now let us say that I am a person who has some sort of restricted memory location, or let's say that I can read only 10 characters at a particular point in time. Okay, if that is the case, then for me to read the entire program or the entire text file that is shown over here, okay, if I want to read the entire text file that is shown over here, then at the start I will place my cursor at the starting location, that is at the first location where I have placed my cursor right now. And from there, what I will do is, I have told you that I have a small issue, I can read only 10 characters once. So I will take the first 10 characters starting from this particular location. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have read from star to O. Okay, I have read from star to O, and R I have not read. Okay, so I have read from star to O. Okay, so I have read from star to O, that is the first 10 characters, and then I leave my cursor at that location, and then when I read the next 10 characters, I will start from R again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so again it will read the next 10 characters, correct? It will read the next 10 characters and leave the cursor at that location which it has to start from next. Okay, so this is the idea of a cursor. Now let us take a look at tutorials point. And I am going to look at file IO, because that is what we are trying to learn right now. Okay, so there is something called file input output. Okay, so you can actually open a particular file using the function fopen. Okay, now the fopen will give a file pointer, or it will return the pointer to a particular object of type file. Okay, and the parameters that you have to pass to the function fopen are two parameters. One is the file name and the second is in the mode which you want to read it, the mode in which you want to open the file in. So in C programming language or in a computer, that is what you need to start with. Okay, in a computer you have two kinds of files. One is called a text file and another one is called a binary file. Okay, and we know that there is something called a cursor in an editor. Okay, so if I use gedit, that is yet another text editor. Okay, so I've just opened gedit. Okay, and I'm just going to copy the contents and paste it into the text editor over here, gedit. I've pasted everything into the gedit. So here, right, the cursor is the blinking place where I have my keyboard pointer. So if I enter something, right, it will enter it in at the place where the cursor is present. Okay, now the concept of cursor is very important. Just a minute, guys. Okay, so the concept of cursor is very important. Why? Because that will tell you that you can read 10 characters, okay, at once, and then you will read the next 10 characters. Okay, so if these are the first 10 characters, then it will read the next 10 characters and so on. Okay. So there is a function called fopen that you will use to open a particular file in a C language, okay, in the C programming language. And the function fopen, right, it takes two parameters. One is the file name itself and the second one is the mode in which we are going to open that file in. And with regards to the mode, right, there are a total of 6 modes, which are R, W, A, R plus, W plus and A plus. R stands for read only mode, W stands for writing mode, A stands for append mode. Okay, now let me show you a very simple example. So I have I have something called echo hello world to new file.txt. So I am going to create, so let me before I run that particular command, right, let me clear the terminal and I do ls new file.txt. There is no file called new file.txt, and at this point I am going to do echo new file.txt. Oh, I'm sorry, this has to be an out direction operator, and I'm just going hello world new file.txt, and I do an ls. The new file is over there, and I try to print what is the content in new file.txt. It prints hello world, correct? Now if I go and execute this command once again, okay, what is going to happen is that it is just going to write to the file new file.txt the content hello world, but it is writing it as a new, it is a separately new file. So it wouldn't have actually done anything if you do the cat new file.txt. While on the other hand, if I put a double arrow new file.txt and then I do a cat, you can see that it has added the hello world to the end of the file. Okay, now So I'm doing echo add something else, double out direction new file.txt, and I do a cat new file.txt. You can see that it has already taken the existing file, added some hello world over there, and then it took the existing file which had 2 lines of hello world and then did add something else. Okay, now if I do, let's say, add again something, and you can see that I have added something. So this operation, right, is called append. Okay, meaning that I will add content at the end of the file. Okay, so this is called append. Now let me do this particular step like this. So this I am saying it is not going to append. This is going to put this content into the file new file.txt. So it will create the file again separately. Okay, say if I do double out direction, then it is going to append content to the end of the file. So why did we learn that? Because I wanted to tell you about the modes. So there are 3 different modes, or total 6 different modes. Majorly read, write and append, then read plus, write plus and append plus. So you can open a file either for only reading, which means that if you have opened it in R mode, you cannot write any content into that file. You cannot put any data into the file. If you put W, right, which means that you have opened that text file for writing. Okay, now as I told you earlier, let us say we started with ls new file.txt, right? It said that that file is not there at all, but the moment we printed something and we saved it into that file, it created that file automatically. So if you open a file in write mode and that file is not already there, in that case the file will be created. Okay, so if it does not exist, if the file does not exist for writing, then a new file will be created and your program will start writing content from the beginning of the file. Why is it writing content from the beginning of the file? Because usually when you open a file in read mode or in write mode, it has to start, the cursor will be placed at the topmost location of the file. Okay, the starting location of the file. While in append, right, when you open a file in append, what it means is that it will not be at the starting location of the file, but it will be placed at the ending location of the file, which means that if I have to append some data to the file and I have opened the file in append mode, the cursor will be placed at the end of all the data, so that we can enter data at the end of the end of all the data. Okay, so that is the difference between the 3 different modes: read, write and append. Okay, then you have R plus, which is opening a text file for both reading and writing. Okay, and then you have W plus, which opens a text file for both reading and writing. but it first truncates the file to 0 length if it exists, otherwise creates a file if it does not exist. So if you open a file in W mode, then it will be created if that file is not existing. But if you open a file in W plus mode, okay, even if the file is existing, the content in the existing file will all get deleted. That is what it means by truncates the file to 0 length. Then you have A plus, which is opens a text file for both reading and writing. It creates the file if it does not exist. The reading will start from the beginning, but writing can only be appended. Okay, so that is the difference between A plus. It will have two cursors, one for reading and one for writing. The reading will start from the beginning and the writing will be at the end. Okay, so if you're going to handle binary files, then we will be using the following access modes instead of the above ones. So if we are using binary files, right, we have to use RB. Okay, read binary, write binary, append binary, RB plus, R plus B, WB plus, W plus B, AP plus, and plus B. So B is the additional thing over here. Okay, so we have seen how we can open a particular file. We can open a file by using the function fopen, passing it the file name and the mode in which you want to open that file in. Okay, and if you will close the file by using the fclose function, and in the using the fclose function you will pass the file pointer. So here the file pointer is the pointer that is returned when the file is opened using the function fopen. Okay, and then you will pass that file pointer to close that file that is opened by using the function fclose. So the fclose function returns 0 on success or EOF, called end of file, if there is an error in closing the file. This function actually flushes any data still pending in the buffer to the file, closes the file, releases the memory used for the file, and the EOF is a constant defined in the header file stdio.h. Okay, so in today's class what you will learn is just the function names, okay, for operating the files. So you have the function name called fopen, then you have the function name called fclose, okay, and there is a concept called end of file. End of file means that just like how we know \o or \0, not \o. \0 is the string terminating character, right? Similar way, there is something called EOF, which is the end of the file. Okay, so the fclose, right, will close the file that is open, okay, and it will return the value 0 if the fclose was successful, or if there is an error in closing the file. Okay, if there is an error in closing the file, then EOF will be returned. Okay, now how do you write to a file? You can let's say if you want to put a character, right, this has to be, I think, let me see, put C, F put C, okay, man. So you have the functions called f put C, f put s, put C, put char, put s, etc. that you can use to write content to the file. So you can pass the character that you want to put into the file, and then you can pass the file pointer also, or you can pass a string and then the file pointer. Okay, so there is an example over here. Okay, here we have declared a file pointer fp. Okay, and we assign the value to fp when the file is opened using the function fopen. We specify the file name. Now over here, right, I want to tell you something. Kindly do not get angry at me, because there are a lot of concepts that need to be explained. So there's something called addressing, relative and absolute. Okay, not for Excel. Okay, so I'm opening another web page which says about absolute and relative path names in Unix. Okay, so let us say we have something called let me do this thing, ls Armstrong. Okay, so we have a file called Armstrong underscore command line args.c, correct? Now if I do pwd, I know that I am in the folder home Anub lab 2021. Okay, I'm in the folder home Anub lab 2021, and the file Armstrong underscore command line args.c is present in the folder home Anub lab 2021. Okay, now if I do cat Armstrong underscore command line args.c, okay, it will print the contents of the file Armstrong underscore command line args.c, and it has printed it because I am in the folder 2021 and the file Armstrong underscore command line args is present in the folder 2021. Let us say I press cd, I type cd and I do clear and I do a pwd. You can see that it is now in home Anub. So right now I am in the home Anub folder. Now I am going to do cat Armstrong underscore command line args.c. It will say that there is no such file or directory called Armstrong underscore command line args.c. Okay, so what I am going to now do is I am just going to do lab slash 2021 slash Armstrong. Okay, so instead of printing instead of just passing the file name Armstrong underscore command line args.c, I have passed it some more information like lab slash 2021 slash Armstrong underscore command line args.c, and I press enter. Yes, it has printed the content, correct? So I have it has printed it in Armstrong. Okay, now I do cd space 2 dots again, and just a second, I'll show you which is the present working directory. I am in the folder slash home, and right now I am going to print the command line arguments, I mean Armstrong underscore command line arguments, and you can say that when I try to print it, right, it said that there is no such file or directory. So let me try to put it as lab slash 2021. What will happen? Will it work? Class irukku. Will it work? Students, if I am going to print it over here using cat, is it going to print anything? It will print that there is no such file or directory. Why? Because I am in the folder slash home. So what I am going to do is, can I give it as Anub slash, yes, it works, or can I give it as slash home slash Anub slash lab? Yes, it works. Now let us say I did cd and I did printing it again. Over here what you need to understand is, okay, let us see history grep. Okay, so you can see that I have actually tried to print the commands that I have tried to execute. You can see that at some places I have tried cat Armstrong underscore command line args.c. At some place I have tried cat lab slash 2021 slash Armstrong underscore command line args.c. At some place I have tried cat anoop slash lab slash 2021 slash Armstrong underscore command line args.c. In another place I have used cat slash home slash anoop slash lab slash 2021 slash Armstrong.c. In this one, right, this Armstrong.c, this lab slash 2021 slash Armstrong.c and anoop slash lab slash 2021 slash Armstrong underscore command line arguments.c. These are all relative addresses. These are all called relative addresses. Relative. What is relative? When two cars are going at the same speed in the same direction, then their relative velocity would be 0, correct? If one car is going at 80 km per hour speed and another car is going at 90 km per hour speed in the same direction, then the relative velocity will be 10 km per hour speed, correct? So same way, if I am in a directory where that file exists, then if I just use Armstrong underscore command line args.c or just the file name, it will work. Or let us say if I am in the folder home anoop, okay, and I know that Armstrong underscore command line arguments is there in the folder lab 2021 in home anoop, then I can also give another relative address called lab 2021 Armstrong underscore command line args.c. Or I can, if I am in slash home, I can give it as another relative address which is anoop slash lab anoop lab 2021 Armstrong underscore command line args.c. So these three are relative addresses, and if I give the complete path, it is called a absolute address, okay, and this is the complete path. So that is an absolute address. Now going back to the program that we were trying to read, why did I tell you about absolute path and relative path? The reason why I told you that is I wanted to tell you about this. Now this is actually a absolute path. This is an absolute path. Why? Because if I do cd slash temp, it takes me to the folder temp. Okay, it takes me to the folder temp. So in the temp folder, we are creating a file called test.txt in w plus mode. Okay, so the fopen function will return the file pointer to the file that is opened. So fp will now have the file pointer to the test.txt which is opened in w plus mode. And then you can do, instead of printf, you have used fprintf. So we will use fprintf fp, which is the file pointer, comma, this is testing for printf, and then you do fputs. Okay, this is for testing for fputs, and then the file pointer. So this file pointer is what identifies to which file we want to print of or which file we want to put the string to, and we use fclose to close the file using the file pointer. Yes, students, do you have any doubts with regards to what we have covered so far? So far we have covered something called fopen, then the modes of operation of a particular file, modes in which you can read or write a file. We have learned about text files and binary files, and with regards to the text files, we have seen R plus A plus W plus modes. With regards to the binary files, what are binary files? Binary files are files which represent the content in binary format, which is not in human readable format. In that one you have to use the mode RB for a binary file. When you are going to handle a binary file, you have to use RB or WB or AB or RB plus or R plus B or WB plus or W plus B or AB plus or A plus B. So B is a common thing when you have to handle a binary file. So we have learned fopen, and then we learned about fclose, and then we also learned about something called the file pointer, correct? The file pointer. So when you have to write a particular program, okay, let's try to run this particular code, okay, and okay, so let's say we are going to put it in the lab folder in 2021, and let's call it as file example1.c. okay, so this is file example1.c, and I'll put it as int main, and I'll put it as return 0. Okay, now I'll go to the folder /10, okay, and I'm going to now okay, jump to 2021, clear gcc file example file example. Yes students, do you have any questions? I see that somebody has unmuted their microphone probably and is speaking. Yes, Kaitan. Can I mute you if you do not have any particular question, because that particular noise is also disturbing the class. Okay, thank you, Yash. Okay, so we have the program. We have saved it as file example. It has compiled, and now let us try to run the program file example, and let's go to the folder temp, and you can see that in the temp folder it has created a file called test.txt. Let's open it with Emacs. Let's see what happens. Is the content there in that file? Yes, the content is, this is testing for printf, this is testing for fprintf, right? Both the content are there, and it has put the file in a folder called /temp, correct? So if I look at the properties of this file, right, let it open, just a second. Yeah, if I open the properties of this file, you can see that it is there in /temp /test.txt. It's a simple plain text file with 60 bytes of storage. Okay, now I'm going to make some change. Okay, instead of giving it as /temp, okay, I'm going to put it as file example underscore test.txt in W plus. Okay, so earlier I had used the file name as /temp /test.txt, which is absolute path, right? And now I'm going to use file example underscore test.txt, which is a relative path or relative addressing. This is address. So gcc, we compiled the file. Now let me check if there are any text files in this particular folder. Yes, there is a text file called new file .txt, which we created earlier, you remember, with the echo. So I'm just going to remove the new file. So new file .txt has been removed, and I go and check whether there are any txt files. No, there are nothing. So I'm just going to run the program, and I'm going to check whether there are any new txt files in this folder. And yes, there is a new txt file, and I go and check what is there in the txt file. It is, again, this is testing for printf, this is testing for test. Is that clear, students? I mean at least this much. So here what we have seen is how to write content to a file. Okay, now you can read a file, and again remember the concept of cursor that I have explained to you. So the cursor is very important, because if you are going to place your cursor where I have highlighted the text right now, the character right now, so when you are going to read, it is going to read from this particular position, right? And when you are going to write, it is going to write at this particular location, correct? So right now what we have seen is, we have seen to print or writing a file. We have seen how we can write contents to a file, and next we will see how to read the contents of a file. Okay, and then we will see binary input output functions, etc. So let us continue from this tomorrow. Okay, so before I tell you that, I want to before we stop the class, I want to tell you something. Okay, so when you are reading a file, you can see that there is a concept called a buffer that is used. Okay, now what is this buffer that is used? So buffer means that, I told you earlier that when we were trying to understand the cursor, right, that I have a problem that I can read only 10 characters at once. So I will read the first 10 characters, move my cursor to the next place where I want to read, and then in the next iteration or in the next loop, I will read the next 10 characters. Then again I will move my cursor to the new location from where I want to read, again read the next 10 characters, and so on. Okay, now imagine a well. Okay, okay, so I am going to tell you about buffer. Okay, so imagine a well with a lot of water. If you want to take water from the well, how will you do? You will take a small bucket or a mug as per availability, and then fill the small bucket or mug with water, and then transfer, and then once the water is emptied, you can fill more water from the well into the small bucket or mug according capacity of the small vessel. Okay, so what you need to understand here is that we are actually trying to imagine taking water from a well. Okay, so a well has a lot of water, and you are given a small bucket. Okay, and you have a big container that you want to fill water with. Okay, so you will fill the small bucket / mug and empty to the container. Once emptied, there is space for water in bucket / mug. You will add, or you will take water from the well again and then empty it to the container. So this bucket, this transfer of water from well to container is limited by the size of the bucket or mug. Okay, meaning that maximum water that can be transferred at once will be the maximum size of the bucket or mug. Okay, so this is the concept of buffer. Okay, so this is the idea of buffer, meaning that if I have to read some, if I have to read content from a file, then I will use a small buffer area and the reading will be limited by the size of buffer. Okay, so I will fill the buffer first, then transfer contents in buffer to program, and once the buffer emptied, then it is filled with next data. Students, so I have told you about something called cursor, a file, text file and a binary file, and right now I am telling you something called a buffer, and I am trying to tell you that a buffer is something similar to a bucket where you want to actually take water from a well and fill in a container. Okay, now if you want to do it that way, then you will have to fill the bucket with the water in the well, okay, and then empty it in the container and keep on doing it. Okay, so at every single point, the maximum water that you can transfer will be the size of the bucket. Okay, so it can be 10 liters or 20 liters. So same way, there is something called a buffer, and a buffer area is an area where you will first fill the contents with. So first you will fill the buffer first, and now then you will read from the buffer. Okay, so the limitation is that if you have a file which has, let's say, 500,000 characters of data, 500,000 characters of data. Now if the buffer is 500, right, then it means that you will have to read a total of 1000 such reads. So you will have to read the first 500 characters, then you will have to move the cursor to the next location, read the next 500 characters, move the cursor to the next location, read the next 500 characters, and so on. Okay, So that is the idea of buffer that I wanted to tell you, and the reason why I told you about buffer is because we have the concept of buffer when you are going to read contents from the file. Okay, so here also in the fscanf, so we know that if we want to open a file, you can use the function fopen. If you want to write some content into the file, you can use the function fprintf or fputs. If you want to read some content from the file, you can use fscanf. But fscanf also requires something called a buffer, and the buffer is mentioned here, okay, which is a 255 character array. So which means that you are going to read 255 characters at once and so on. So that is the idea of buffer, and that is the reason why I told you about buffer. We will continue with reading a file from the next class. So today what all have we covered? We have covered dynamic memory allocation. We have read about malloc, free, and then we have read about
realloc.
Yeah, realloc, and then calloc as well, right? Those are the 4 things, and then we looked at a better explanation to what char star argv is, right? So in the earlier class that we had the day before, that is the previous week, I had told you that it refers to a 2-dimensional array, but in reality when I looked at it closer, I thought that explanation may be confusing, because it is actually an array of character pointers, while in reality you can actually use that to define a 2-dimensional array also, but it is not a 2-dimensional array, but it is an array of character pointers. Okay, so that is one thing that we have learned, and then we learned about files, binary files, text files, cursors, and then writing data to a file. And with regards to reading data from a file, we have learned about buffer. So yes, Bhadraksh Bhargava, do you have any questions? Bhadraksh Bhargava, are you there in the call? Yes, he is. Okay. Am I audible? Okay, nothing.
Yes, sir.
Yes. Okay. Thank you, Abhishek. So, do you have any questions with regards to the topics that we have covered so far? So, so one thing that I want to tell you is, when we are working with C programming language, it is very important that you create a complete picture of what all you have learned, okay, because none of these topics are none of these topics are irrelevant, okay. Every topic is relevant, and if you want to get a clear understanding of what everything is, you should actually start writing programs, okay. So you have seen that you can use all the concepts that you have learned so far with files also, okay, or whatever concept that you have learned so far with malloc also, or whatever concepts that you have learned so far with command line arguments also, okay. So you should understand this subject in such a way that the first things that we have learned towards the starting of the semester were the real building blocks, the very smallest parts which build the entire system, okay. And then we have slowly built one on top of the other, and we have learned so many things, and we are almost at the last position, but I would say that there are still bit more things that are not covered in this entire syllabus, so we will try to cover that as well. So which means that you can understand that this whole subject becomes very enormous, right? And the scope of the kind of programs and everything also becomes very large. Okay, so that is something that you need to understand very clearly. Okay, so that's it, guys. I just gave you a quick recap of what all we have covered in the class and what we will be covering next day. Next day we will be looking into writing into the files, and we will also be looking into binary files. Do you have any questions? Any further questions?
No, sir. No question.
No, sir.
Okay.
No, sir.
No questions. All right. If there are no questions, then I think I will leave. Let us meet in the next
Sir,
class.
sir,
Yes,
sir, in
Abhishek.
that sir, in that CS assignment 1, do we have to write algorithm also, sir?
Yes, you have to.
That pig Latin one.
I didn't get you.
Sir, the pig Latin one
Yes,
program.
you have to. You have to. Okay. So now for the lab assignment, today is the last. We will be done with all the lab assignments by today, and the lab assignment for today is. Let me bring it into the correct place. CS101. And it is CS101. Okay, lab assignment 8, which is already available to you. Okay, that is lab assignment 8. There's only one question over there. Okay, given a file input.txt, read the file to find out the number of characters, number of words, and number of lines in the file. So that is the question. Do not start doing it today. Of course, if you start doing it today also, that is fine. But this is a question that you need to do for this last final lab assignment, and after this we will have more practice questions which I will bring to you. Okay.
Sir, in this we
Yeah.
have to take that text file, or text file is given, sir.
Yeah, so I am saying that a file called input.txt is available to you. Okay, your task is to read the file, find out the number of characters in that file, number of words in that file, and number of lines in that file.
Okay, sir.
Okay, yeah. That's it, guys. So I'll stop I'll leave the meeting. Let us meet in the next class. Okay, there is a question from Bhadraksh Bhargava. Sir, what should be the content in file? Anything, or you have given some file? I have not given any file. It can be anything. It can be anything. It's a text file. It's not a binary file. So it can have the entire content, like this. It can be this file as an input.txt file, or it can be any of the C files that we have given, or it could be anything. It's just a simple text file. Yeah, that's it, guys. Do you have any other questions?
No, sir.
Okay, thank you, everyone. I'll stop now.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.